So this will be our third example in your equilibrium forces. Third example. Okay. So let's read the problem. The ball D has a mass of 20 kilograms. If a force of F is equal to 11 or 100 newtons, so meaning 100 newtons daw yung F natin, is applied horizontally to the ring at A, determine the dimension D, so that the force in cable AC is 0. Okay. So what would be our dimension D? So that this AC or your CA is 0. Ibig sabihin wala yan. Para walang force yan. Para hindi siya magbubuhat ng kahit anong force. Zero ka magiging parang loy-loy siya. Wala siyang bubuhatin. Wala siyang tensional force. Or your FCA or your TCA is equal to 0. Okay? So, considering this problem, so balik tayo sa principle ng equilibrium natin. But before that, let us resolve this 20 kg mass into its weight in Earth. So, Ft or gravitational force is equal to mass times gravity, which is equal to 20 multiplied by 9.81, right? So we'll have a value equal to 20 multiplied by 9.81. We'll have a value equal to 196.2 Newton. That is our Ft. So our F is equal to 100 Newton. So let us solve this one. By our principle, summation of f of x is equal to 0 and our summation of f of y is equal to 0. Okay. Via summation of f of x is equal to 0, so our summation of f of x is equal to FBA, positive, negative. Take note, pag ginawa natin to ng free body diagram, ikakat natin to. So this force is going away with the body because it is a tensional force. So we'll have negative. Bakit siya negative? Because the direction of the arrow is going to the left. So we have negative FBA cosine theta. Cosine theta. Let this be my theta. Okay? Theta. Okay? Next is our 100 Newton. So positive yan because it is going to the right. So it was further stated or initialized that your summation of f of x is equal to 0. So I will substitute this to the summation of f of x. So we'll have 0 is equal to negative FBA cosine theta plus 100 Newton, right? So therefore, I will have a value of my FBA. My FBA is equal to FBA cosine theta is equal to 100 Newton. Can you solve for your FBA? Not yet, right? Because there are two equations, two unknowns. Since there are two unknowns, we need two equations. Kung ilan yung unknowns, yun dapat yung equation mo. Pag there are 5 unknowns, you must also have your 5 equations, right? Okay. So our next equation will be, of course, your summation of f of y. So I will just initialize this as my first equation. So my second equation will be probably in our summation of f of y, right? So summation of f of y equals 0. So ibahin natin yung kulay ng ballpen natin, right? Your summation of f of y is basically equal to f BA, right? Going up, FBA sine theta is equal to, so summation of f of y to. So positive yan, So positive FBA sine theta going up less the FD or your gravitational force at D. So we will have our FBA is equal to FBA sine theta less our FD, which is initialized as 196.2 Newton. Take note that this is the gravitational force or your weight. Okay? The summation of F of I later on is equal to 0. So 0 is equal to our FBA sine theta. So FBA sine theta less 196.2 Newton. So I may say that I will have a value equal to FBA sine theta, ito transpose natin yan. So we'll have 196.2 Newton. So how will you solve this again? By dividing your equation 1, equation 2 divided by your equation 1. So let's say this will be our second equation or your equation 2. So equation 1 divided by equation 2, we will have equation 1 divided by equation 2. So we'll equation 2 divided by equation 1 para makukuha tayo ng tangent. Para hindi na tayo magpipythagorean, no? Or mag hexagonal plane. So we have our equation 2, we have FBA sine theta divided by my FBA cosine theta. So it is equal to our FBA sine theta, we have 196.2 newtons divided by our 100 newtons. So siyempre matatanggal lang yung newtons mo, matatanggal lang din yung FBA mo. So we'll have a value equal to sine theta divided by cosine theta, which is equal to 196.2 newton divided by 100 newton. But what is your sine theta divided by cosine theta? Take note that this is just your tangent theta, tama? So we'll have tangent theta is equal to 196.2 divided by 100. We will have a value equal to 1.962. 1.962. Take note that unitless yan. That is unitless. Okay, because you are talking about your angle. So therefore, my theta can be solved using how? Mahalaga ba yung theta natin dyan? So let us reread the problem. The ball D has a mass of 20 kg if a force F is equal to 100 Newton is applied horizontally to the ring at A. So determine the dimension D. Ito yung tinatanong natin, dimension D. But take note that I initialize this one as my theta. Right? Theta to. Okay. Basing it on the problem or on the figure or on the free body diagram, how will we solve for your theta? Take note that tan theta is similar to our opposite over adjacent. In this problem, our opposite is equal to this length, right? Your 1.5 plus d. So therefore, I may say that my tan theta is equal to 1.5 plus d divided by my adjacent angle is my 2 meters. Okay, that is my tan theta. Knowing for this equation, I may solve for the d directly. How? By initializing, let's say, this third equation to your fourth equation. Since this equations is similar, which is they are both equal to theta, therefore tan theta is equal to tan theta. I may say that tan theta is equal to 1.5 plus d divided by my 2 or my adjacent, which is equal to 1.962. Solving for D, so for further manipulation of the formula, pwede kayong mag-SIP solve or pwede kayong mag-mathematics lang. Okay, 1.962, cross multiply mo yan. Cross multiply mo yan dyan. So we will have a value equal to 3.924. Transpose mo yan dyan. So less 1.5 is equal to D. So therefore, I may solve for my D, which is equal to less 1.5. Our D is equal to 2.424 meters. 2.424 meters. That is our answer. So I'll just box the final answer, which is equal to 2.44 meters. Okay. So let us recap for the step. My first step is that I will draw the free body diagram by cutting all the ropes and then initializing it force going out the body because it is tensional force. And then after drawing my free body diagram, I will make sure that this diagram is in equilibrium on the basis of the problem that it must be at summation of f of x is equal to 0 and your summation of f of y must be equal to 0. Since this body tends not to rotate, therefore I will not use my summation of m of m is equal to 0. So after initializing those conditions, I wrote the component method of forces, which is summation of f of x and summation of f of y. Then after solving for those equations, I solve for the value of your theta, and then knowing that your theta is equal to opposite over adjacent, which is 1.5 plus d all over 2, which is also equal to our tan theta of your forces. So therefore I equated this tan theta, and then equating your two tan theta which has equal tan thetas, therefore we may solve for the value of my d, which is equal to 2.424 meters. Okay.